Why does outlier detection carry such weight in the realm of data science? To answer this, imagine a single piece of data skewing your entire analysis, leading to inaccurate predictions and misguided decisions. That's the power of an outlier. One of the most effective techniques for detecting these statistical anomalies is the Local Outlier Factor, or LOF. The LOF method operates on a simple principle. It quantifies the outlierness of data points by comparing their local density to that of their neighbors. Sounds intriguing, doesn't it? So let's dissect how LOF works step by step. Firstly, the method requires a clear definition of what constitutes a neighborhood for each data point. This is typically defined by a distance metric, such as Euclidean distance, and a parameter that specifies how many closest data points should be considered as neighbors. Once the neighborhoods are established, the local density of each data point is calculated. This is done by estimating the distance from a data point to its nearest neighbors. A data point surrounded by many close neighbors has a high local density, while one with few or distant neighbors has a low local density. The next step is to compare the local density of a data point with the local densities of its neighbors. If a data point has a significantly lower local density than its neighbors, it is considered an outlier. This comparison is quantified by the LOF score. An LOF score greater than 1 indicates an outlier. The higher the LOF score, the more anomalous the data point is. Conversely, an LOF score of approximately 1 suggests that the data point is just an ordinary member of its neighborhood. The beauty of the LOF method is its sensitivity to local structure. It enables the detection of outliers that may not be noticeable in the global context, but are conspicuous when considering their local neighborhood. Now, you may wonder, where do we apply this LOF method? The applications are, in fact, quite diverse. LOF can be employed in fraud detection, where transactions deviating from typical patterns can be flagged as suspicious. In healthcare, LOF can help identify abnormal patient readings that could signal a medical condition. In environmental science, it can highlight unusual weather patterns or pollution levels. To sum up, the Local Outlier Factor method is a powerful tool in the data scientist's arsenal. It operates by defining neighborhoods, calculating local densities, and then comparing these to identify outliers. Its sensitivity to local context allows it to detect outliers that might be missed by other methods. And its applications are broad, spanning from finance to healthcare to environmental science. Remember, in the world of data, it's not always about fitting in. Sometimes, it's the ones that stand out that hold the most valuable insights.